Hello, my name is Siti Nur Izzatul Arabia. My magic number is 312954. First, I will explain about the first part, which is definition of calculus. To know about calculus, calculus is a branch of mathematics that study change and accumulation. It has two main parts, which is differential calculus, study rate of change, motions and optimization, and second part is integral calculus, which is focused on accumulation area under curve, distance and volume. Calculus is used to model and solve a real-world problem and essentials in engineering, physics, economy and technology. Next, I will introduce Tenaga Nasional Berhad or TNB. Founded in 1949, TNB is the largest electricity company in Malaysia. The company is responsible for generating, transmitting and distributing electricity across the country. TNB plays as a key role in supporting Malaysian infrastructure and economic development. Here is 1.3, the background and introduction of Toklof Corporation Berhad, which is Toklof is Corporation Berhad founded in 1991 in the world's largest rubber glove manufacturer, producing medical and industrial gloves for global market. With over 50 factories, that company focus on innovation, automation, quality control, and sustainability to meet increasing global demand. The chosen operational process in monthly glove production, which is suitable for mathematical modeling. By analyzing factors such as raw material, machine capacity, and labor, Toklof can optimize production, control costs, and respond efficiently to market demand while maintaining product quality. The operational process chosen for TNB is a daily electricity demand. Electricity demand is measurement is kilowatt hours per day. Is influenced by factors such as weather condition, time of day, and consumer behavior. By using mathematical models, TNB can forecast demand accurately, maintain grid stability, and manage electricity generation efficiently.
My name is Sofia Christina. In this section, the operational processes of both companies are represented using the mathematical function. The functions chosen are continuous and differentiable, making them suitable to describe change in consumption and production over time. This approach helps represent realistic operational behavior within a fixed time period. In this section, the operational processes of both companies are represented using the mathematical function. The functions chosen are continuous and differentiable, making them suitable to describe change in consumption and production over time. This approach helps represent realistic operational behavior within a fixed time period. For Tenaga Nasional Berhad, the constant value of 120 represents the base monthly electricity consumption. The coefficient 10 shows the early monthly increase in consumption, while the negative coefficient of minus 0.4 indicates a slowdown in growth due to technical limitation. This behavior can be seen clearly in the graph. For Toklof Corporation Berhad, the value 215 represents the baseline production level. The coefficient 2 shows steady growth, early growth, while 1.0 indicates accelerated growth during the mid phase. The negative coefficient, the negative coefficient of minus 0.05 reflect long-term production constraint. Overall, positive coefficient indicate growth, while negative coefficient reflect the operation limitation as shown in the graph. The quadratic function is suitable for TNB because it clearly shows rising electricity consumption followed by a slowdown due to capacity constraint. The cubic function is suitable for top gloves as it model multiply production growth pace Realistically, both functions are continuous and differentiable, making them suitable for derivative and integral analysis. This model helps simplify complex operational process into understandable mathematical representation that supporting planning and decision making.
Next is 3.0 mathematical derivation for the function from part 2.2. In this part, we're going to change the function to a derivative function. First, 3.1, we're going to find the derivative function for the Tenaga Nasional Berhad, TNB. So, the demand function of TNB is defined as dt equals to 120 plus 10t minus 0.4 t squared, where t is an element of 0 to 12. To find the derivative function, we're going to differentiate the function terms by terms. d prime t equals to dt over dx, 120 plus 10t minus 0.4 t squared. 120 is constant. When we differentiate it, it's going to be 0. So 10t, when we differentiate it, it's going to be a 10. And minus 0.4 t squared, when we differentiate it, it's going to be minus 0.8 t. So the derivative function for TNB is d prime t equals to 10 minus 0.8 t. This derivative represents the instantaneous rate of change of electricity demand with respect to time that measured in gigawatt hours that can be written as GWh per month. Interpretation for the TNB derivative function. The derivative d prime t provides insight into how fast demand is changing at any given month. When d prime t greater than 0, the demand is increasing, while when d prime t is less than 0, demand is decreasing. For example, we assume a few values within the domain. T is an element of 0 to 12. At t equals to 0, d prime 0 equals to 10 minus 0.8 times 0 equals to 10. It shows that demand is initially increasing at 10 gigawatt hour per month. At t equals to 12, d prime 12 equals to 10 minus 0.8 times 12 equals to 0.4. It shows the demand is still increasing but at a slower rate of 0.4 gigawatt hour per month. Next is 3.2. We're going to find a derivative function for Top Glove Corporation Berhad. The production functions given is defined as Qt equals to minus 0.05 t cube plus 1.2 t squared plus 2t plus 250, where t is an element of 0 to 12. To find the derivative function, we also need to differentiating term by term. Q prime t equals to dt over dx minus 0.05 t cube plus dt over dx 1.2 t squared plus dt over dx 2t plus dt over dx 250. 0.05 t cube, when we differentiate it, it's going to be a minus 0.15 t squared. 1.2 t squared, when we differentiate it, it's going to be 2.4 t. And dt over dx to t, when we differentiate it, it's going to be a 2. And 250 is a constant, so when we differentiate it, it's going to be 0. So, the derivative function for the Top Glove Corporation Berhad is q prime t equals to minus 0.15 t squared plus 2.4 t plus 2. Interpretation for the Top Glove Corporation Berhad derivative function. Q prime t represents the rate of change in production or sale with respect to time. It shows how quickly production is increasing or decreasing in any given month. The magnitude of Q prime t tells us how steep production is changing. Positive value of Q prime t indicate increasing in production, while negative value of Q prime t is indicate decrease in production. If Q prime t is greater than 0, the production increasing at that month, and if Q prime t is less than 0, the production is decreasing at that month. We move on to the example. Assume a few values within the domain. T is an element of 0 to 12. At t equals to 0, Q prime 0 equals to negative 0.15 times 0 squared plus 2.4 times 0 plus 2, and it equals to 2. This shows that production is initially increased to 2 million units per month. While at t is equal to 6, Q prime 6 equals to negative 0.15 times 6 squared plus 2.4 times 6 plus 2, and it equals to 11. This shows that production is growing strongly at 11 million units per month. At t equals to 12, Q prime 12 equals to Negative 0.15 times 12 square plus 2.4 times 12 plus 2, and this is equals to 9.2. And this shows that production is still increasing but at a slower rate, 9.2 million units per month.
For T&D company, the function is given. To find the critical point, first we have to differentiate the functions. Then we set the derivative equals to 0 and solve the equations. The answer is T equals to 12.5. In Top Glove Corporation Berhad also the function given. To find the critical point, first we have to differentiate the functions. After we differentiate, we simplify the functions and the derivative is set equal to 0 to find the critical points. This result in the equation is 0 equals t squared plus 16t plus 13.333. Using the quadratic formula, the critical points are found. The solutions obtained are t equals negative 0.794 and t equals 16.794. Since only positive value of t are meaningful in this context, t equals 16.794 is considered as the relevant critical point. Classification for T and B, we differentiate the first derivative and the answer is negative 0.8. This derivative is less than 0, so the function is represent a maximum value and no minimum value is obtained. Classification for Top Glove Corporation Berhad. The first derivative is given and we differentiate became second derivative. The critical point are substituted into the second derivative. At 2.6382, it will represent a local minimum. At negative 2.6382, it will represent a local maximum. The point of inflection occurs when the second derivative is equal to 0. Solve the equation and the answer is 8. The total output for Tenaga Nasional Berhad is obtained by evaluate the definite integral of the function from 0 to 12. The result is 1929.6 units. The total output for Top Glove Corporation Berhad is determined by evaluate the definite integral of the production function from 0 to 12. The result is 1363.2 units.
5.1, which is discussion. First, calculus provide a powerful mathematical framework for analyzing and solving real-world problems. That involves continuous change through the application of differential calculus. Complex systems such as motion, growth, and optimization can be examined by evaluating rates of change and critical point. Integral calculus further complements this by enabling the calculation of accumulate quantities such as total distance, area, volume, which are essentials in practical application. The integration of calculus concept allows for accurate modeling and prediction of real-life phenomena across various fields, including engineering, economy, and natural science. Overall, the use of calculus enhances the problem-solving efficiency and support informed decision-making by translating real-world situations into precise mathematical models. This table compares TMB and Top Glove TMB use DT to show electricity demand over time, while Top Glove use QT to show production output. TMB focus on demand and seasonal growth, whereas Top Glove focus on production efficiency and steady monthly growth. Based on the observation, Tenaga Nasional Berhad show a fluctuation in its operation due to seasonal change in electricity demand. This makes a demand forecasting more challenging and require continuous adjustment in power generation. In contrast, Top Glove Corporation Berhad show us a steadier growth pattern in a monthly production, which make production planning more predictable and easier to manage. As a result, Top Glove appear to benefit more from the application of calculus model, particularly in prediction of production output and optimizing operational costs. In conclusion, Top Glove Corporation Berhad is the more efficient company due to this steady growth and lower variation in production, which market costs easier to predict. Tenaga Nasional Berhad shows stable long-term growth and potential lower marginal costs, but its operations are affected by a demand peaks that can increase the operational costs. Overall, Top Glove benefits more from a mathematical and calculus model as they allow accurate production forecast, better inventory planning, and improved cost control. This justification is simple, steady and predictable trends like those of a third globe are easier to optimize using mathematical models. In contrast, variable demand as seen in Tenaga Nasional Berhad makes it more challenging to readily solve a calculus for accurate forecasting and operational planning.